Okay, we're going to look at a couple of proofs here. My battery's kind of going low. We're going to zero in right here on this one. Right here. Okay, so what it says is, given that AE bisects BD, let's go ahead and mark that. We'll come back. And angle B is congruent to angle D, prove that triangle ABC is congruent to DBC. So let's mark what we have. What do we know? What are we given? B is congruent to D. And for your proof, that's your given. So I'm going to mark B and D congruent, right? It's given to you. I'm also given that AE bisects BD. And on the paper it should AE. AE bisects BD. That's also given. So let's see now what we can do with these givens. Well, this is pretty much done. B and D are congruent. That's it. There's nothing else I can do with that. I just mark them congruent. But that word bisect, what does bisect mean? It means cut in half. So AE, which is this one right here, cuts BD in half. That means that C, the point where AE goes through, is in the middle. So I can say that BC and CD are congruent by the definition of bisector. Because that's what it's saying. AE is the bisector. This is the bisector of BD, so that means it cuts BD in half. Then I need to look at what else I can figure out from the drawing. And the other thing I can figure out is I've got my special favorite angles here. I've got verticals. So angle ACB, which is this one, is congruent to DCE, which is this one, by the vertical angle theorem. Or if you want to write vertical angles are congruent, you can do that too. And so to close it, what do I have now? I have an included side between two angles, so that is going to be the angle side angle theorem. Okay, so that's an example of a proof. We'll do one more where you're going to have to do some proofs from scratch, but I'm giving you some blank ones here just to kind of help you out a little bit. Let me widen this out so we can see this a bit better. Working with this camera has been kind of a pain in the rear. All right, so what we're going to do is we're going to look at this picture. It says given N is the midpoint of MO. So that if I were to go over to my proof, I can see that already says given. Okay, that's my given. It's already there. All right, go back to my picture. Okay, LM is congruent to OP. So I'm going to go back to my proof. LM is congruent to OP. That's given. And that's already marked for you. Then you're also given that LN is congruent to PN. So you got three givens right in a row there. So let's look at what we can do with these givens. All right, you're given these sides, and then you have to kind of figure out, well, what else can I do? Well, what does it say about N? It says N is the midpoint. What does that mean? It's in the middle, which means what? MN has to be the same length as NO. So I'm going to come over to my happy proof here, and I'm going to say MN is congruent to NO. And how do I know that? That's what the definition of midpoint. The midpoint told me that. So now I can actually go ahead and move on and finish this by saying, and you're proving, it tells you the prove here. You're going to prove triangle LMN is congruent to triangle PON. And again, we just established that that's side, 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 and you're done with that proof. So that's how you would prove it. Okay? Now the last thing I want you to look at here is look in this box, and we come in a little bit here. Let's look at this box right here. Which side is congruent automatically just by looking at this picture? And that would be BD. BD will be congruent to BD. Can you tell me why? What property is that? Reflexive property. That's the reflexive property, okay? What other parts must be congruent in order to use side, side, side? Well, if I want to use side, 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 I've got to match up the appropriate pieces. They're not saying you know they are. They're asking which ones would have to be. Kind of like the previous video where you had to find the third congruence. Now it's like which one. So if I want to use side, 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 that means I got to match up all three pairs of corresponding sides. So that means AB would have to be congruent to CD. And AD would have to be congruent to BC. That's in order for us to use side, side, side. Okay. Now, what if I wanted to use side, angle, side? So we're going to pretend we don't know anything, again, but the reflexive, and I want to use side, angle, side. Well, there's multiple possibilities. Multiple. So I'm just going to pick one. I would have to know that angle BDA was congruent to angle CBD. So I've got a side and an angle. And then I could either say CD is congruent to AB. Whoops, wrong sides. Thanks for catching my error there. So I would have to, if I want to do side, angle, side, I would have to say AD is congruent to BC. I would have to say that this one and this one, because that's what would create the included angle, side, angle, side, side, angle, side. Or I could have done that angle and done this side and this side. So it's kind of open on that one, as long as you know both. So if you look at these, you can tell this is just a kind of a compilation of congruent triangles. And I'm going to put the videos of the proofs from scratch into the playlist for this review so you can look at those as part of the review.